Today we will discuss Kadane's algorithm by solving the maximum subarray problem. Let's start by reading the text of the problem. Given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. So, as you can see in the example that LeetCode gives, we have to find the largest sum of contiguous integers in a given array. In our case, the output is 6 and the subarray that gives us this sum is composed of 4 minus 1, 2 and 1, and together they give 6. So now that we understood what the problem asks, let's think about edge cases. We can assume that there is one array which satisfies this condition. So the other edge case we can consider is that if the array contains one element only, the maximum subarray is the element itself. Okay, so now we have clear what the problem wants from us and we consider the edge cases. Let's move to the tablet to draw the algorithm so that we can understand better how to code it. Actually, the idea behind Kadane's algorithm can be summed easily as following. Look for all positive contiguous segments of the array and find the maximum. We use dynamic programming by keeping track of the maximum sum at each step. Each time we get a positive sum, we compare it with the maximum sum we kept track of and update it if it is greater. So let's enumerate the three simple steps of Kadane's algorithm. Step number 1. Iterate through the array and keep a current sum. Step number 2. Use dynamic programming to keep a current max. If the sum is greater than the current max, then the current max becomes the sum. And step number 3. If the sum is less than 0, then it is inefficient to move forward and we reset it back to 0. So, in the end, to simplify this even further, we can think about only two steps in order to always remember Kadane's algorithm. 1. Keep track of the max so far. 2. If sum is less than 0, reset it to 0. So now let's draw Kadane's algorithm on this example I have picked so that everything will be more clear. As we can see, the max subarray for this specific case is 6 and it is comprised of the following subarrays starting at 4 and ending here at 1. So now that we see what is the correct response of this problem, let's start to get to it by drawing each step so that we can just understand better and visualize better Kadane's algorithm. Also, I have put a color for each step so that I will show you the value of our variables at each step without writing every step specifically. I'll just write the values so that we can understand better and not go on a different page where we cannot see our array in front of our eyes. Cool. So, as we said, what we do, we will keep a current sum, which I will call it sum, which will be equal to our previous sum plus nums of I. Then I will have a current max, like we said. Let's just call it current max, which will be the max between the previous current max and the sum. And then we will say if sum is less than 0, we will initialize it to 0. And we say that by doing this. We say sum is max between the sum and 0. Cool. So I will initialize my sum to 0. And I will initialize my current max to minus infinity. Perfect. So now let's start. I will put again the variables here so that we can debug nicely, so we can understand what we are doing. We have sum and we have current max. Cool. Let's start. So sum is the previous sum, which is 0, plus nums of I. In this case I is 0, we start at 0, we said yellow. So 0 minus 2 is minus 2. Current max is the max between the previous current max, which is minus infinity, and minus 2 will be minus 2 as well. Now sum, if it's negative, we said that we will reset it to 0. In this case it is negative, so I'm going to reset it to 0. Perfect. Now we will increment I. Now I becomes 1. Again, sum is the previous sum, which was 0, plus nums of I, which now is 1. Sum becomes 1. The current max is the max between the previous current max, minus 2, and the sum, which in our case is 1, so minus 2 and 1, maximum is 1. Now, since the current sum is more than 0, we will leave it as it is. We don't have to reset it. We move to I equals 2. In this case, again, sum is the previous sum 1, minus 3 is minus 2. Now the current max is 1, so the current max will be the maximum between the previous one, 1, and minus 2 in this case, so it stays 1. But now because the sum is less than 0, we will reset it to 0. And we move to I equals 3. So I equals 3, which means that nums of I is 4. So sum is now 0. 0 plus 4 equals 4. Current max is now 1. And now we have the max between 1 and 4 equals also 4. Now we see that the sum is more than 0, so we don't need to reset it to 0, and we move to the next step. Now, sum was 4, it becomes 4 minus 1, 3. Current max is 4 compared with 3, it's greater than 3, so it stays 4. Sum is greater than 0, so we don't need to reset it. And we move to the next step. In this case, we are nums of I equals 2. So sum is the previous sum, 3 plus 2, 5. Current max is 4. Now we have the max between 4 and 5 equals 5. Once again, sum is greater than 0, we don't need to reset it. And we move to the next step. In this case, nums of I equals 1. So sum becomes 6. Current max will be the max between 5 and 6, so it will also take the value 6. Since sum is greater than 0, we don't need to reset it, so we move to the next step. Good. Now nums of I is minus 5. Sum becomes 6 minus 5, 1. Current max will be the max between 6 and 1, will stay 6. Sum is greater than 0, we don't need to reset it, so we can move to the next step. So we can see nums of I equals 4, sum becomes 5, current max, it will be the max between 6 and 5, so it will stay 6. Sum is greater than 0, so we don't need to change it, and our iteration is done. And now what we will do, we will return current max, which in our case is 6, as we have seen here. And this is how we reach the correct response with Kadane's algorithm. As you can see, it's comprised of 3 simple steps, and honestly, if we want to, like I said before, if we want to really remember it well, we can only remember the fact that we keep a sum and a current max, which current max will always be the maximum between the current value of current max and the sum that we just calculated. And the second step is that if sum is less than 0, we reset it to 0. And that's it. Very simple. Another observation we can make is that if the sum up to the nums at I is less than the nums at I, so if sum up to, let's say from here to here, nums at I, including nums at I, it's less than the nums at I itself, let's say in this case 4, then we will reset the sum to the nums at I, right? And I think it makes sense, because if the sum up to nums at I, including nums at I, is less than nums at I, it will only drag us down to keep it moving forward. So instead of resetting it to 0, as we did in the previous example, we'll just reset it to the value of nums at I. So given this, let's also draw this so that we can understand how this works, of course. So I'm gonna go back and I'm gonna say that I will keep two variables as well in this case. I'm gonna have a temp max, which will be 0, and I will also have a global max, which will be minus infinity. Now temp max will be equal to the max, like we said, between nums at I, as we said before, and the sum so far. So temp max plus nums at I. And the global max will be just as the previous example, will be the max between temp max and the global max. Cool. So let's go through this example as well. Let's start with, so we say here we have temp max and we have the global max. Cool. And we reached our result, 6. And now I will return global max, which in this case is 6. Perfect. So you see, in both ways we reach the same result. You can actually implement any of those two because the time complexity in both of them will be O of n. Oh my god, I cannot write n. So once again the time complexity will be O of n, because we have to go through the whole array. We are iterating through the whole array. And the space complexity in this case will be O of 1, because besides the array, which is the input value, we are just initializing temp max and global max. So now let's code our solution. We will code both versions of the solution as we saw in the drawing. So let's start with the first one. First, let's initialize our two variables. So current max will be integer.meanValue and the sum will be 0. Now let's iterate over the array. 0, I is less than nums dot length is plus. So we add to the sum our nums of I, sum plus equal nums of I. Then the current max will be the maximum value between the sum and the current max, and the previous current max actually. And now we reset the sum to 0, and we do that by saying sum is max between sum and 0. Yeah, so if sum is less than 0, then sum will become 0. And now all we have to do is return current max. And that's it. Let's run the code, see if we have any errors. Seems to go. Let's submit it. And it works. That's it. Quite simple, right? We see here the 3 steps. It's quite a simple problem. Now let's code our second solution. So for our second solution, once again, we initialize our 2 variables. We have the global max, which is integer in value, and we have the temp max, which is 0. Once again, we iterate over the array. Let's nums with length plus. So here we say that we have one step less because we don't need to specifically reset the sum to 0 here. So we say that our temp max equals math.max between nums of I and the sum up to nums of I. So temp max plus nums of I. Then global max will be the maximum between previous global max and temp max. And that's it. Now we just have to return global max. And there we have it. Let's run also this code, see if it goes well. Looks good. Let's submit. Yeah, looks great. Don't necessarily look at the time and the memory usage because sometimes it has to do with internet speed. And that's it. I really hope that what I explained was clear enough, and if not, please leave your suggestions in the comments below. Also, if this helped you understand Kadane's algorithm, please give this video a like and please subscribe as more content is coming. I will do more LeetCode problems and more complex tutorials about building different cool applications using different technologies. Thank you for watching and see you in the next one.